All right, guys, so we are going to go ahead and look at comparing features of tables versus graphs. Okay, so this is a super important topic, guys, because we are now trying to look at not just, okay, do we understand graphs and how to interpret those graphs, but also looking at the information in the form of a table. And one of the reasons that this is so important is because if anytime we're like, oh, okay, like I know we did this in class, or I've done this before, but I'm just like completely drawing a blank. I have no idea how to graph. We can always make a table of values. So we're like, okay, well, here's a table. Let me pick some X's. I'll substitute them into my equation. I'll get the Y's and be able to interpret them that way. But if we don't understand how tables work and how to kind of compare them to graphs, it's going to be more difficult. So let's go ahead and get started. Okay, so first we're going to go ahead and figure out what we're looking for. So when we scroll down, we can see that we're looking for the y-intercept. So before we even get started, let's talk about what we know about the y-intercept. So y-intercept. We know for one, and in terms of a graph, it's where the graph crosses the y-axis. Now, in terms of a point, it's always going to be the point 0, y, meaning the x value is always 0. So those are the main things that we know about the y-intercept that's going to help us with this problem. So when we look at it in terms of a graph, it's crossing the y-axis right here, because this is our y-axis, at the point 0, -1. So let's go ahead and start entering that information in. Now, something we have to make sure that we're careful of, it says note the x and y intercepts write only a number and not the point. So it wouldn't make sense if we wrote 0, right? So we're going to write -1. So the y-intercept of f of x, and all it's saying is that this is f of x. So this top one is f of x. This bottom one is g of x. Now, also when we get to this table, please remember, guys, that g of x is the same thing as saying y, or f of x is the same as saying y. So it just, instead of saying, if you all raised your hand again and everybody's name was Bob, and I was like, cool, Bob, go ahead and answer the question. Well, like, which Bob? And so the same thing here. Okay, well, this is the y-intercept of this graph and the y-intercept of that graph. Well, if they're all named graph or y equals, we can't differentiate between them. And so that's why we give them these fancy names, f of x and g of x. It's a way to differentiate between them. So now for the y-intercept of g of x, we said when we're looking at a table, it is the x value is 0. So here's the x column, right? Well, where on here is x 0? Right here. So this is called the y-intercept. So if I were to graph these points, that point would be on the y-axis. So then the y-intercept for g of x is 2. And it says f of x has a blank y-intercept than g of x. So is it greater or smaller? Well, -1 is definitely smaller than +2. And so then that's going to be our result. So again, here we're just practicing our vocabulary terms. We just look at the y-intercept. We're going to look at the x-intercept and then the minimum and the maximum. So we're practicing those vocabulary terms. And then we're looking at how do we identify those values in different forms, graphically and in a table. So let's go ahead and start looking at the x-intercept now. Okay, so for x-intercepts, we're actually not looking at a parabola because most parabolas, right, which is the focus of this particular unit, is most of them have 2 x-intercepts, and so it's going to be hard to compare to a table if there's 2 of them. So the idea here, guys, is that we're just comparing and showing what we know between the x and the y-intercept and then the min and max. So what do we know about the x-intercept? Well, we know it's just like with the y-intercept, it's where the graph crosses the x-axis. And it's always going to be the point x comma 0, meaning the y value is always, I can't write very well today, okay, is always 0. So when we look at this graph here first, we say, okay, well, here's the x-axis. Where's my graph crossing the x-axis? Well, here at the point 4, 0. Now, again, same as the last time, it said for x and y intercepts, write only the number. And so since it's 4, we're just going to write 4. And then for g of x, well, we said again that the x-intercept is when the y value is 0. So here's, again, these are the y values. So where's the y value 0? Right here. And so this would be our x-intercept. So again, just continuing to practice our vocabulary and being able to demonstrate what we know about those terms. So f of x has 4 is greater than 3. So f of x is greater than g of x in terms of the x-intercept. Okay, lastly, let's go ahead and look at the minimum and maximum value. Okay, so the minimum or maximum. So before we get started, we need to talk about what that means. So a graph like this is a parabola. This has what we call a maximum. And the maximum is the y value of the vertex. And well, the minimum is also the y value of the vertex. But notice our vertex, that's right here, again, where the graph is kind of changing direction. The vertex is the highest point on our graph. Whereas when we have a minimum, again, it's the y value of the vertex. But our graph would look like this. And again, that being our vertex, because the vertex is the lowest point. It's not, our graph is not going to go past this point. It's going from this point and up. And the vertex up here is going, the graph is going from the vertex and down. So that's our difference between minimum and maximum. So before even reading the question, well, I'm telling you we're doing a minimum maximum problem, but we can tell that this graph is going to have a maximum because it's the highest point. So before we can actually find the minimum and the maximum, right? So we need to know, well, okay, if we're finding the y value of the vertex, what exactly is the vertex? Well, the vertex is kind of where the graph changes direction, right? And if we think a little bit more into that, if we think, okay, well, this is our axis of symmetry. Again, we've already learned about that vocabulary word. And it's the same on both sides. So if we were to graph this or talk about these points, this would be 1, negative 5. This, it might not be perfect, but we're going to just say it's approximately 2, negative 6. Again, it's not exact, but close enough to prove my point here. And this is at 1, negative 6. And if we were to keep going, you'll notice how when we have that vertex, it has a different y value, but it's creating a pattern on both sides. So if we were to continue going on, we'd have like negative 7 and negative 7 and negative 8 and negative 8 for the y values. And so it continues a pattern. We can kind of find out where that middle point is. So when we're looking here, the maximum, because again, the maximum is where the y value of the vertex. So here's our vertex at 1, negative 5. So then the maximum would be -5. So if we scroll down here, the maximum, so you have to know the difference, it's a max because it's going upside down, of f of x is -5, and there is no minimum value. So if it has a max, it doesn't have a min. Okay, well, we have to figure this out here. So we're going to kind of make a very rough graph of what this would look like. Okay, it looks like it's going to be like really low on the y-axis. So the points we have, let's call this 0, -35 here. And then we have 1, -20. Again, very rough drawing. 2, -11. 3, -8. 4, -11. And 5, -20. Again, very basic idea, but the basic in terms of just like, so something like this, right? Is how our graph would look. Notice we have this pattern, we have this -8 in the middle, and then these two are the same, and then these two are the same. That's showing us that this is our vertex or our middle point. So and if we look at our graph, it's upside down again. And so just like that first one, it is going to have a maximum. The maximum, again, it's the y value, so it's -8. You could also think it's maximum because that's the biggest y value we have, is the middle one. And then again, there's no minimum. If it has a max, it doesn't have a min. If it has a min, it doesn't have a max. So f of x has a, well, -5 is actually bigger than -8. So it's actually a greater value, and they're both a maximum. So it's showing you here again, there's our max at -5. Here's our vertex, okay, because it's again where that pattern is, and that's at -8. And they're both maximums. And so then we're comparing those maximums. Both of them don't have a minimum. Now, since the max and min are new, we looked at x and y intercepts all the way back to when we were graphing lines. So I didn't want to take too long on those, but let's do one more minimum maximum problem to kind of get a little bit more of an idea here and maybe hopefully notice a few more patterns. So here we go. Here's another minimum maximum problem. So this time it's going to have a minimum because it's the lowest point. And so our vertex is right here at 1, -2. So we do have a minimum, and the minimum is going to be -2. Again, it's a y value of the vertex. So let's go ahead and plug that in. So it has a minimum of -2, which this time now means there's no maximum. Okay, now let's look at here. So let's see. So we have the 3's in common. They both have 3. There's a 9 on either side. And so then our vertex is going to be this point here. So this is our vertex, the point 1, 1. And so our either min or max is going to be 1. So that's the y value of the vertex. Let's just create a really basic drawing. But again, kind of once you get the hang of it, I think that you guys will kind of see those patterns and be able to go through it a lot quicker and just be like, oh, that's a minimum or that's a maximum. So I'm just going to start from here. So -1, 9. Let's just call that -1, 9. 0, 3. 1, 1. 2, 3. So before I even finish, hopefully you guys can see, just like the last one, this is going to have a minimum, even with a super rough drawing. So this one's going to also have a minimum. In fact, I don't know that I've even come across one where there's a difference. Like, I think they always have to have the same, both minimum or both maximum, but it's always good to verify. So then the minimum is +1, and there's no maximum. So therefore, f of x has a, well, -2 is definitely smaller than +1, and they're both minimum values. Okay. So today, guys, in this lesson, we reviewed x-intercepts, y-intercepts, and then the minimum and maximum of a quadratic, or like of a parabola. We looked at comparing both the graph to the table and what we know about, what information we know about all of those things in terms of a graph versus a table. Now, if you guys have any questions, as always, please let me know. Otherwise, good luck on your homework.